Hello everybody, welcome to Clean Code in Python. Let's talk about quality code in our favorite programming language. My name is Mariano Anaya. I will upload in the presentation, and the idea is to explore some things. First, if you try to define what is clean code, you'll find that there's not a sole definition of clean code, and instead you will find probably many definitions as developers available out there of authors. But among all of them, I'll pick this one by Ward Cunningham, who says that clean code is one in which every function does pretty much what you would expect as you read through it, and that you can call it beautiful code when it also makes it look like a language was made for the problem. And that last sentence is the reason why I think this is a more accurate definition, because this is what we call pythonic code, or idiomatic code in Python. So throughout the rest of the slide, we'll see what is pythonic code and how to achieve this, and most importantly, what features that Python provide in order to have maintainable code. So if you had to think or to say one thing about clean code, you can say that a clean code is focused. It does one thing and does it well. And that thing that it's doing should be pretty much what you would expect when you read the code, meaning that you shouldn't be guessing or reverse engineering the code. And this is important for many reasons, because arguably the quality of the code will determine the quality of the software. We know there's a string correlation between a code that is complicated, and as a result, the software, the product, has a lot of bugs and it's harder to maintain. Whereas the opposite is true. If you have a maintenance code base, it's less likely or had severe bugs, and even if they are there, they'll be easier to spot and correct. So basically, the degree to which you can read the code and actually understand what it's doing is actually highly important. We all know from the sense of Python that readability counts, which makes perfect sense, because if you think about it, as developers, we spend much more time reading code than actually writing code. Whenever we want to make a change or add a new feature, we first have to read all the surroundings of the code we're going to modify or extend, and for that we need a code that we actually can maintain. So this is somehow related to agile development in the terms that if you want to actually ship changes or features effectively, we need a code base that we actually can work with, which is also related to the fact that the code is a part of the design. Back in the old days, we used to think that there were some design documents or models, and from them we derived the code. But nowadays, we know like the code is part of the design. The code is just, and we have to treat it as a design document or as a design model, such as if we were a class diagram, etc. And for that, we need a code that we can read and understand. On the other hand, we have some things that are exactly the opposite to what we want. For example, code that is not intention revealing, and that is not expressive enough, that is complex or obfuscated. Code that is duplicated is actually probably the worst thing we can have, because all of these are actually, in the end, forms of technical debt. And technical debt is something that jeopardizes the project, but it's an underlying problem, and that is much difficult to spot or identify. So we want to actually get rid or have as less technical debt as possible. And the first idea I'd like to introduce is the concept of meaning, and by this I mean how expressive or how able the code is telling now what it's doing. So imagine I have this function that, given a year, it has to print 1 day per each of the year, and this actually works. This actually prints aloud in the console per each time of the year. But now suppose that, I don't know, 6 months or a year passed since I first wrote the function, and I find myself revisiting the code again. And something is not quite clear. In particular, this line is not actually very declarative, and I find myself trying to reverse what it's trying to do, and I say, okay, maybe it's trying to figure out if the year is divisible by 4, and now by 100, it's trying to do something, and if that condition is met, it's adding an extra day. So I say, maybe it's trying to figure out if the year is sleep or not. But that's the problem. The fact that I had to guess is the problem. I shouldn't be guessing anything. If I want to figure out if a year is sleep or not, I already have a function that resolves that problem for me, and I can just simply read the code. So something that simple as this is probably really powerful, because this is probably the simplest kind of change you can make to the code that at the same time adds the most of the value. Remember that functions are the first line of organization in any project. Functions should do one thing, they should do it only, and they should do it well. So they should have a single responsibility. And the reason why this is a simple yet powerful concept is because it works as building blocks for other concepts on top of that. For example, code duplication. If we think about it, most of the time, code gets duplicated because of the lack of meaningful abstraction. Somebody that has a validation there in the code that it's an inline method or something, and then somebody comes and say, okay, I need something that is similar to this, so I will copy and paste it here, I will change the 1 by the 2, and I think, okay, I'm all set. But actually, without we knowing it, we perhaps duplicated code inadvertently because that code didn't have a proper meaning or proper label to it. And duplicated code is the worst we can have, because it forces you to do parallel changes, and when you have to change something, you have to do it many, many times, and you forget one of them, you have a bug, and there is a problem. So we actually want exactly the opposite. We want that for every part of the code, there should be one single place where to make a change at any given point of time. And that was the so-called DRY principle, which stands for don't repeat yourself. And in order to achieve this in software engineering, there has been many improvements or enhancements. For example, libraries, frameworks, tools, design patterns, etc. And those are great, and we should keep them in mind when designing our own code in Python. When it comes to Python, we can say that we can have a so-called extra tool, which are decorators. I'll not talk in depth about decorators because that's probably a topic for another talk, but basically the high-level idea is that there are functions that can modify our callables in the code and return a modified version of the original one. And we can see that how we can use that to our advantage in order to remove duplication. So consider this scenario. Suppose that I have to maintain the status of a database, and for that I have a script that someone else is going to be called, and we are written on this API. So the idea is I'm going to be executing every command in the sequence against the database, and at that point, if an exception occurs, I'm going to log the exception and return -1 because that's the agreed status call. And if everything works fine, I'm going to log that completed successfully and return 0. And this actually works, again, just at the beginning. But now I have another requirement, which is I need to move some records from a table to an archive table in order to move historical data. And I say, OK, I can do the same with 2 commands of SQL statements. One which is going to insert the archive data, and then I'm going to delete the affected rows from the main table. But then the rest of the logic follows the same pattern, and it's actually the same code as before. We can see that, again, it's executing every command in the sequence. If an exception occurs, it's logging the exception and returning -1. Otherwise, it's returning 0. And now we see the problem. We see that when there is a second requirement, the code was not extensible enough. It was repeated. And the reason why it's duplicated is probably because it didn't have a proper name or it didn't have a proper label to it. Instead, it was anonymous code trying to log something or return the status code, and it was tempting to do this duplication. So now I'm going to create another function, which I'm going to call dbStatusHandler, and it's going to encapsulate that logic. And it's going to be a decorator, and details don't matter, but the high-level idea is that it's going to assume that it's decorating the original function that it's going to receive, assuming that function returns the sequence of commands that need to be executed with the database. And this is going to encapsulate all the logic. So dbStatusHandler is in charge of running all the commands on the database, logging an exception if something went wrong, and returning -1, or returning 0 and logging if everything worked fine. And now the previous 2 functions can be changed for something like this. I only have to apply the decorator on top of the function definition with @dbStatusHandler, and then I can change and remove all that logic away and just put the command that needs to be run in the database. And now by doing so, we achieve 3 things, actually. First, we put a name to something that was previously anonymous code, something that didn't have a name. Now it's called dbStatusHandler. It has one rightful place. Second, there is a separation of concerns. Now, the previous function only knows about the login and the error handling and knows nothing about the commands, whereas this function has the exact same opposite behavior. These only know about the commands they're going to be running and don't know about the logic of the error code handling. And third, and most obvious, well, we remove the duplication because now the code is defined in only one place. So by using decorators, we actually separate the concerns, and we remove and abstracted away logic that was repeated and exposed. So there are many cases on which we actually have to deal with implementation details, which as part of accidental complexity. Scenarios in which we have something that is part of our core functionality, something we actually want to do, and some other accidental complexity that in general is related to technology that we cannot escape from. And we want to keep that as separate as possible in order not to entwine things that might lead to code being harder to maintain. So we'll see what Python has to offer on this. So consider this scenario now in which we have an online application with players playing online. And this object represents the status of a player at a given point, basically the point that it has, etc. So after a game finishes a match, I want to update the points with the new points that players scored. So I have a method like this, which is accumulate points, and I pass the new points. But if you take a look at the implementation, it's not actually something very nice, because we see that it's handling with Redis, a connection with the key, 0, which seems to be a default value, then follows what I actually want to do, which is accumulate new points. And then it seems that I'm, again, dealing with Redis and the key, etc. So it turns out that this is not highly expressive. So if I want to get the points of a player at a given time, I must just write points. If I want to set them, I can do points equal anything, like I do with any other regular Python variable. So the previous example, the accumulate points, well, it turns out there's nothing particular about it. It's just plus equal 20 or any number, which makes things much more simpler and abstracts that logic away. So in order to achieve this, we can implement this with a property, which is a built-in decorator in Python. And I will encapsulate all the details of the technical parts into there, so the user doesn't have to know there is a Redis connection or etc. And it doesn't even have to know or agree to a specific API. It only knows that there's a point, and they can accumulate or try to assign a variable, and it works. So in general, it's a good idea to use properties for this set of cases when we have to do some computations on our attributes of the object. And basically, we should prefer this approach as opposed to writing custom getters and setter methods, because that may be well for other languages, but in Python, it's just better to keep things simpler, because it's more Pythonic. So the idea is that with this in mind, it also becomes easier to read and also easier to test, because now we can unit test this with any object that has a dot point attribute. It doesn't have to be a real one. I don't have to have a Redis connection or patch it or mock it. It's just a simpler way of solving things. Now imagine the case of we have a searching algorithm. Now suppose I have an online application that sells products online, and this object, this class represents all the products that I have stored by categories. And at some point I have a view that looks like this, and is in charge of handling the scenario when a customer wants to make a purchase. And this is too complicated to read, but I go through the hassle of reading it. And near the if statement, I found something that is like a clue, which asks if product available in stock. And I see the problem, which is pretty much at the beginning, because again, I'm reverse engineering the code and trying to do the decorators trying to do. So I say maybe those all previous lines were actually trying to figure out if product was available in stock. And now, if I want to figure out if a product is available in stock or not, I might rather just simply write that, if product in current stock, which makes perfect sense. And it makes the code to speak in terms of the domain problem. This is actually almost as reading a business rule in the code. So in order to achieve this is because every time we write something like this, if product in current stock, Python will translate that and call the magic method contains, and will pass the object as a parameter. So now with that idea in mind, I know that, okay, maybe I can implement contains in stock class, which actually, by the way, makes perfect sense. I move all my searching algorithm and my logic there, and now I can rewrite my code in much more expressive fashion. So sometimes the answer is in the magic method. Sometimes there's a magic method that makes your code much more expressive and easier to deal with. In our cases, we have to maintain state, meaning we have to run our first logic, the business rules. And we also have to keep the system in a consistent state. Sometimes that means, for example, we want to make sure we don't leak file descriptors, or we don't leave connections open to a database, or we want to remove temporary files, etc. And again, we shouldn't fall into the trap of putting everything into the same place, because that will be harder to maintain and to test. So consider this example. Let's say I have to run a backup of my database, but the backup is offline. So I have to stop the database, run the backup, and then I will start again. And one way I could do this is by means of a context manager. And context manager are a fairly simple protocol in Python that only have two methods, enter and exit. And when I do something like this, I'm going to put the code that stops the database into the enter. So I use this with a with statement. So when I run with and an object that follows this protocol, Python will first run the enter method. So there I will stop the database service, which stops the service in Unix. Then it enters the context manager block, and then I will run the backup. And the function that runs the backup only does that and nothing else. And then after the last statement completes, Python is going to exit the context method and is going to call under exit, even if an exception occurs, which makes things even simpler or easier, because I don't have to deal with exceptions or error codes, etc. And in that code, I put the logic of starting the service again in order to make sure that I'm leaving the system in a consistent state no matter what. There's a slightly better way to improve this and save some boilerplate in some cases by extending the context decorator interface available in Python 3. And if you implement under exit and enter, you can then apply this as a decorator. And this means that every time the function is being called, it's going to be called inside the context manager, so you don't have to put it. So it's a nice way, and in some cases you can use it. So the idea is that, in general, Pythonic code means to use the features of a language. That means to actually make sense of the features. And a good idea to know that we're achieving this, if you're writing code in a way that blends well with Python reserved word in a meaningful way, pretty much like the if product in current stock example. And you can do the same with for loops or with, I don't know, with context managers, etc. So those are probably a good thing to keep in mind. So to wrap up, we can say that in general, the best way to find, to achieve Pythonic code is to actually take advantage of the features of the language. That means sometimes using a context manager, sometimes using a decorator, sometimes there is a magic method for that. The important thing is to keep that in mind and to keep the code readable, because this is what we should care about when doing a code review on evaluating a pull request. On a side note, there are other tools you can use for having a good code, which are, for example, all the static checks or compliance with the standards. But the reason why this is different or separate is because it's not actually about having PEP8 or any going style. You can be 100% compliant with PEP8 and still not have a Pythonic code, because again, Pythonic code is achieved by using or expressing the code in meaningful ways. So these are things that we should leave to the machines or to run automatically with scripts or bots as part of the continuous integration and not worry about in doing a code review. In a code review, we should ask things like, is this code readable? Is this code understandable? Does it make sense? A new person joining the project will be able to understand it the first time it reads the code. So that's actually a good user of time. It's actually a good idea to put docstrings or function annotations in order to hint your readers about the functions or what they expect in order to receive or return, because Python has a dynamic nature and they make sometimes things harder to trace. Everything I mentioned about the code also applies to unit tests, because in the end, unit tests are part of the code base. And also having unit tests and writing unit tests will help you write better code, because things like in the first example, like the function that takes about the leap year, that will come cleaner or more clear in a unit test. You want to test that and you will realize that it's coupled. And naturally you will realize, oh, I need a function to separate this. So by having unit tests and by having the mentality of writing tests, you will naturally follow a more maintainable code. Finally, we have some tools that we can use. For example, PyCode style, Fleckade, PyLint, that will give you metrics about the code. In particular, the last two, PyLint and Radon, will also give you metrics about, for example, cyclomatic complexity that you can use as a head start in order to identify places of the code that need more refactor urgently. And also Koala, which is a tool that lets you even define your own rules in case you have a particular standard, and can also work with the previous tools as a backend. So the idea that I want you to take from the talk is that it's not about standards or it's not about the code. It's not also about knowing all magic methods by heart or all features of Python. It's about having like the right mentality of the mindset of that I need to look for something in Python. Like writing that there's always a better way or a more Pythonic way. And a good clue to find that is like usually, for example, try to take a look at the methods of the data structures or objects that I'm using, and that will give you sometimes the clue of what's the better way of writing tests. For example, if I'm using a dictionary, try to see what methods provide dictionary that can help you solve the problem, because most of the time, the problem we're trying to solve is already addressed with Python. So basically, if you are particularly interested, there are some resources that I use for the talk. In particular, the two books, Clean Code and Code Complete, are more general of software engineer. They're not specific to Python, but they're also very good sources for this talk. Let me know if you have any questions, and thank you very much for listening to our video. Thank you.
Perfect. Thank you for the talk. It was pretty quick, so we have some time for the questions. I think that there is, we have one Slido question. So doesn't following dry and using decorators reduce readability? Wouldn't it be better, be more readable to call a function to execute list of statements in your example?
Yes, actually, first, examples are just for illustration. It's not real nor practical code. Yeah, so maybe the examples are sometimes a bit forced. The idea is that decorators in general are good tool for reusing code or duplicating code. Sometimes that means to hide or encapsulate. Yeah, could be the case, but in general, it's worth it, or it's even worse to have code that is duplicated. And also, I don't think it reduces readability because we all know basically how the scripters work. So if you think that something is too magic, you can inspect the decorator and see that the logic is there. And also, it's not the only way of reusing code. I mean, I could just have used another function, and that could have worked as well. I don't know if that answers the question, but yes, basically,
We can ask if it was sufficient answer.
maybe the example, yeah, maybe the examples are just toy examples. They're not just actual productive code. So in that case, maybe, but in general, no.
Okay, cool. Does anyone in the audience have a question that I would just give you the mic? Okay.
Hi. Are there any machine learning tools to automate making code clean?
Machine learning tools?
Yeah, something that reads the source code and try to figure out how to make it cleaner to apply, I don't know, some design
Not that I
patterns.
know of. No machine learning tools. There are static analyzers, things like, for example, Pylon or Radon that can tell you, for example, analyze the cyclomatic complexity and tell you this code is too complex, it has too many statements nested, etc. But it doesn't use machine learning, doesn't use artificial intelligence. I don't know of something that uses artificial intelligence for that. I know there are tools, but they are just regular tools that use, or maybe use the AST or something like that, but not like Pylon. But they don't use AI as far as I know.
Okay, thanks.
Perfect. We have another Slido question. Are you familiar with Solid? Had you tried to port it to Python?
No, actually, no. No, I haven't implemented in Python. No.
That was a quick one. Do we have some more? Anyone? Okay. So I think that the talk was so self-explanatory and so full of information that everybody got their answers. But if you will have any further questions, you can definitely reach out to Mariano, because he will be here tomorrow. He will have another talk in the main hall. So he will be available in case you will have any further questions. So, well, we finished a little early, so you can go check the paper and sign up for the lightning talk. And now we will thank Mariano and all move into the main hall, okay? Okay. So thank you very much.
Okay.
Thank you.